Hey guys, I thought about doing another quick video on dilations. I think what's important on this one is trying to figure out if you enlarge it, make it bigger, or make it smaller. We're going to make it bigger here in a second, but when you make it bigger, does anything change? What changes, what doesn't change on an enlargement or a reduction? So I'm going to do an enlargement because if I do a reduction, I'm going to get a really, really small triangle. So we're going to expand this. Let's do it by 2. So let's say we're going to take our ordered pairs and we're going to multiply them by 2. So multiply the x by 2 and multiply the y by 2. So I'm going to double its size, or double the lengths, which basically ultimately would really pretty much quadruple the area size. I'm not quite sure yet. I haven't done it in a while, but obviously we're going to make it much bigger. So let's take our ordered pairs. This is let's call this one here. Let's do traditional ABC here. ABC. Okay. So A is at -2, 1, 2, 3. B is at 1, -1. And C is at -2, 1. And then what we're going to do is we're going to take our ordered pairs. Let me write that down here. We're going to take our ordered pairs, which was the -2, 3, 1, -1, -2, 1. And what we're going to do is we're going to multiply everything times 2. Okay, we're going to find our new, remember this is your pre-image, and this is our image. So we'll multiply everything by 2. So this will become -4, 6. This becomes 2, -2, -4, 2. Okay, I'm going to put that in red so we don't get confused. We don't confuse the image with the pre-image. So -4, 6 is going to end up being 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So A prime is going to end up being here. B is going to end up at 2, -2, 2, -2 right here. C is going to end up at -4. 1, 2, 3, 4. -4, -2. Oh, I didn't do that, did I? See, -2, -1. Oops. It should have gone down. Okay, I messed up on that sign. Anyways, -4, -2. It goes right here. Okay, so that's C prime. So let's connect our dots. I'm going to do this by hand, just because it's going to be a little bit quicker than me taking this ruler here. And then, well, on this one, I don't think I can do. I don't think I can freehand that one. This one's going to end up pretty close to the other one. Let's see if I can. I don't want to hit those writings. Okay, there we go. Basically ends up like that. Alright, now, the point I'm trying to make is what changes, what doesn't change. Well, obviously the length measurement is going to change. It went from a 4 to a 1, 2, 3, 4, 5, 6, 7, 8. Right? So you had a measurement of a 4 here to now a measurement of an 8. Alright? And I'm not going to do all the other sides, but basically you can tell that the sides have doubled. Right? This 3 creates a 6. And this, believe it or not, was a 5. On the black, it's a 5. On the red, it's going to be a 10. This is what I basically taken was a 3, 4, 5 triangle, a Pythagorean theorem triangle, a right triangle, and I doubled it in size. So, okay. So that changes. The sides change, they all double. Okay. Now, what does not change? If you've noticed, my right angle, that was a 90-degree angle here, is still 90-degree angles here. That does not change. This 37-degree angle here it's still 37 degrees here. So those angle measurements will still stay the same. And this is also 53 degrees. So, what changes? The side measurements. They double in size. What does not change? The angle measurements. The angle measurements will always stay the same. So if you ever see a problem that says, hey, I've got two triangles, let's say triangle ABC is, I'm doing another example here, but let's say it was 60 degrees, 50 degrees, and 70 degrees, right? And then triangle DEF is, let's say, one angle is 50 degrees, the other angle is 70 degrees, but we don't know that third angle. Okay? Well, if you notice, they have the same pair of angles. The only thing that they're missing is a 60-degree angle. This has to be 60 degrees. Main reason why is because a triangle, no matter what the measurements are or whatever is in there, the sum, the total of all three angles should always be 180 degrees. So you know that if you added those two, if we add those two and subtract it from 180, the missing angle is going to be 60 degrees. That's what we're missing here. So if your angles, if the combination, the sum is 180 degrees, they're going to be congruent to each other. Okay? They may not have the same side measurements. It may be a reduction, it may be an enlargement, but they will be very similar because they have the same measurements. So that might be something that you want to take a look at, is can you justify whether one figure is a dilation of the other? Can you justify that one is similar to the other? If they have the same angle measurements, they are. If they don't, they're not. So that's the big thing about dilations, is when you compare the two figures, the angle measurements should be the same if it's a true dilation. If they're not, then you did not properly dilate it, or it was not dilated. Hopefully that helps. Let me know if you have any questions about this. Guys, God bless. Talk to you later.